Hello everyone, welcome to the third class of manual material handling. In this class I try to focus on the prevention of low back injuries which may cause by MMH tasks. During the last two classes you practiced a little bit how to use NIOSH equation and Snook tables to predict the weight limit for different tasks. And in this class, I want that you read Garg's paper. This is another approach to MMH. In this approach, they evaluate the energy expenditures and metabolic rate of different tasks. And I want that you go through their methodology. I don't want that you learn the equations, but I want that you understand the concept. In this class, I mostly focus on the prevention modalities and prevention measurements for the low back pains that may caused by MMH. From your previous exercise physiology classes, you learned that for evaluating the energy expenditure of a single or specific task, we can evaluate the physiological responses such as the O2 consumption or the heart rate. VO2 and heart rate mostly reflect the aerobic capacity of a person, but in general, we can say that they are very good criteria for evaluating the metabolic cost of a task. For working condition, it's a little bit different because we are not just dealing with one type of activity. During a work, different tasks will be done, and so they have different energy costs. Therefore, by a single measurement, we cannot reflect the workload. This is the mentality of the study that have been done by Garg and his colleagues. So they developed a regression equation to predict energy expenditure for manual material handling. How they actually divided a job to some subtasks, and then they evaluated the energy expenditure for each subtasks. And then they presented the energy expenditure of whole work by the summation of those energy expenditure of the subtasks. You can see in this table that Garg et al. By the regression models, they could develop different equations and different prediction models for energy expenditure for different type of tasks, MMH tasks such as stoop lift or squat lift or arm lift. And many other researchers have also tried to develop the models to predict the metabolic rates of a variety of manual material handling jobs. And it's important because we can not only understand or estimate the metabolic cost of work, but also we can show in which particular components of the job the worker may be under higher stress, and so by a good job design we may reduce the level of stress for those workers. As you can see, different factors have been considered in Garg's model, such as body weight, the weight of the objects, the lifting height, and the gender. There are some also limitations. For example, we need to evaluate the individual standing metabolic rate in order to apply the models properly, or most of the evaluations have been done in sagittal plane, or the subjects of this study were not very well trained, that which may affect the metabolic rates. But in general, I can say that the Garg's model is more flexible to predict the metabolic rate, and it's more most commonly used. This table shows you different equations related to the lowering activities, and you can see that we have different type of lowering activities such as a stoop, a squat, and arm lower, and for each one a separate equations has been created and developed. I really suggest that you or recommend you to read the article that I uploaded for you. And you can see that how they reached to these numbers and to these equations. I don't want that you memorize these equations. It's impossible, I know. And nowadays there are so many apps that you can use and just put the numbers. But I want that you understand the concept. During these 3 last classes, including today, I wanted to show you different approach to MMH, manual material handlings. And you should consider that lifting capacity cannot be determined only by one stress source, or just for example, by physiological stress. We have biomechanical stress, we have psychological stress, and all these stressors should be taken into consideration when we want to have a preventive strategy. Imagine a person is lifting a very light load. In this condition, the energy expenditure may be very low. So it's not a costly, energetically, I mean, a costly work. But at the same time, the person have biomechanical stress on their back, because of the type of loading, because of the bending forward, of the type of posture that they take to do the job. So all these stressors should be evaluated when we want to design a plan to prevent back injuries. We talked about the biomechanical stress before. The point is how much moments can be produced around this fulcrum or pivoting point. In this case, the pivoting point is L5S1, for example. So you can see that the gravity pull the body when we lean forward, and also the weight that we want to handle downward in a clockwise rotation. And the muscles in our back should produce another moment to resist this force. And you can see when we ask the person to bring the box closer to the body, actually will decrease the moment arm, because moment is a result of force and moment arm. And you can see that when the box is closer to the body, we have a smaller moment arm, so we have smaller moment, and the muscles need to produce less moment to contract the moment of gravity. And when we have stronger muscles in the back, we actually have more efficient moment production in the body to again for this resistance. So you can see that it's important the position of the body, the amount of the load, the distance of the load, and the strength of the muscles all can play different roles in biomechanical stress on L5 spine or other lumbar spine during the movement or MMH. You can imagine how much force our muscles should produce to resist the force which is applied by gravity on a load. And because they have lower moment arm, they need to produce more force to create the same amount of moment. There are some structures in the body, in the spine, that can somehow modify this force distribution. And these are the intervertebral discs. Intervertebral discs have a center portion which is fluid, which is containing with fluid and jelly substances, and there is a thick fibrocartilaginous ring around that nucleus pulposus that we call it annulus fibrosus. There are some end plate cartilaginous pieces in both sides of each vertebrae that somehow attached to the upper and lower part of the discs as well as the bony area. During the standing position, you can see that we have a compressive load on our spine by the gravity, and this compressive load is applied to the nucleus pulposus of our discs, and can be homogeneously can be distributed in nucleus pulposus. But we have also tensile load in annulus fibrosus. You can understand that we have a limitation of movement by facet joint in the back of a spine, and especially during a standing position, these facet joints somehow limit the torsion movement of the spine. But when we are in bending position, this limitation may be less, and we have more space for twisting movement. When somebody is leaning forward or leaning backward or to the side, the nucleus pulposus deforms in direction opposite to the motion, and we have more tensile load in one part of annulus fibrosus, more compressive load in the other side of annulus fibrosus. So it's not homogeneous now. So you can imagine that most of the injuries are happening when we don't have a homogeneous load in the disc, in our vertebral discs. So it's in bending position, and when especially when bending or forward bending position is combined with the torsion. I need to explain two other biomechanical concepts to help you understand the biomechanical stress in low back pain. One is in the left side, the stress strain curve. We use this curve to understand the strength of a tissue. By stress, I mean the amount of force per area of the tissue. So when a tissue has a larger area, the amount of stress is less. And by strain, I mean the percentage of changes in the length of the tissue. So for the certain amount of changes in the length, we have increasing of stress inside the tissue until we reach to the yield point. Before the yield point, if we remove the stress, if we remove the force, the length of the tissue will be back to its normal length. But after that, if we apply, even by applying less force or less stress, the changes of the tissue length may happen. And it has a limit. This phase is a plastic phase. It means that the tissue size cannot be returned to its normal size, and it will change by applying force until we reach to a point which is the ultimate strength. After that ultimate strength, the tissue will be broken down and we will have injury of the tissue. In the right side, you can see a stress cycle curve. By stress, I mean the cyclic stress ranges, and by number, I mean the number of cycle until the tissue reach to the failure. And you can see that here stress somehow represent the strength of the tissue. You can see by applying a certain number of cycle, the tissue can reach to a point that after that point, the quality of tissue will change, and we call it the failure of the tissue. The tissue has very low strength and low capacity to stand the external force. Let's be back to MMH. You know, MMH is the most common cause of low back pain, and a worker may have back injury because of a sudden movement or it's a single episode when they lift a very heavy load, which is much more beyond the capacity of the person's muscles and the musculoskeletal system to resist, and they will have different type of injuries because of that single episode. Or they may have trauma because unexpected events. For example, a worker is carrying a heavy load and on an uneven ground, and so he may trip and fall, and so it may cause injury. But most of the injuries related to MMH are because of the repetitive type of actions and tasks. And therefore, you can see the effect of fatigue in producing low back pain following manual material handling tasks. This fatigue can be tissue fatigue, as I explained to you before, because of cycles of loading and repetitive loading of the tissue to reach to that fatigue point or failure point. Or it can be somehow the fatigue in general, muscle fatigues, physiological fatigues in general, because the energy cost of the person is too much that they cannot replace it due to the type of job that they are doing. And also, it can be mental type of fatigue. And when a person is in that mental type of fatigue, they have less alertness regarding the risks of the work that they are doing, and they may have less caution. So as you can see, we can have different type of fatigue. We can have tissue fatigue, which means that the tissue cannot produce enough force to resist the external force, and is in failure situation. We can have muscle fatigue because of production of lactic acid and also deprivation of glycogen. We can have psychological fatigue, which can be a more sophisticated component. So the fatigue can be central or peripheral. And therefore, work pace, time pressure, the stressful situation of the work all can affect the rate of tissue fatigue, muscle fatigue, and also they can affect the risk of back injury. If you look at the literature, you can find many articles that explain the association between job strain and low back pain, as well as the association between job demands and low back pain. I suggest you read this article, which has been recently published, and they explain about the psychosocial risk factors and how these psychosocial risk factors could affect the low back pain prevalence. Considering all the things that we talked about, the MMH, about the different approaches to MMH and all the factors that can affect the back strain during MMH, we can understand how we can prevent this problem. There are so many guidelines in the literature you can find in different websites. The things that I'm explaining to you are derived from Canadian Center for Occupational Health and Safety website, as well as the publications that are related to University of Waterloo. Different workplaces may have their own safety criteria. I'm sure that you have heard about ISO standard, and you can find a lifting standard in iso.org. So based on the ISO standard, 25 kilogram is the limit for males and 15 kilogram for females. But it's under ideal conditions. And by ideal conditions, I mean the criteria that I've written here for you. So I mean standing symmetrically, trunk in upright position, horizontal distance to object less than 25%, 25 centimeter, and etc. So you know the ideal conditions cannot be for everywhere. Sometimes in some workplaces we don't have these ideal conditions, so we need to somehow predict or estimate that load limit. The first point to prevent back injuries is eliminate heavy manual material handling tasks. How we can evaluate whether the load is high? So you learn different models and different methodology to evaluate the weight limit. If the load is much higher than weight limit and our lifting index is higher than 1, it means that the load is too much and it may cause injury. So we need to do something related to that heavy load, either recruit more workers or use mechanical aid. You should remember that the different models that we use to evaluate the work limit or load limit, they are not perfect, but they work. And some of them have their own limitations. For example, you cannot use NIOSH equation in any condition. I mentioned some of the conditions that maybe you need to decrease the safe limit because they are non-ideal conditions, and so the equation of NIOSH may be underestimated. It's very important that you educate your people how to do manual handling tasks to prevent back injuries. In some countries, they have even back schools. I mean, the special type of training, it's called back schools, that they teach people how to do lifting, how to do different type of movement, how to strengthen the muscles. And and different studies in different countries have shown that it's really effective. So most of these recommendations, or all of these recommendations, are based on physiological, biomechanical, and psychological aspects of injuries. And our understanding is evolving, so we may have better recommendations in future. For example, we may teach our workers to have a good stability during lifting activity. Their feet should be shoulder width apart, with a stable base, and they can use the lower limb muscles plus their back muscles by flexing the knee during the lifting. And by flexing the knee, they use actually their lower limb muscles. It's not just the force production, it's not just the job of the back muscles, and so the force application to the spine will be somehow distributed on the lower limb and the spine together, and pelvic area. So we may have less risk of injury. You can ask people to hold the load closer to their body. You remember that by this recommendation, you actually decrease the moment arm and also decrease the moment of the gravity, and help your back muscles to produce less force and do the job with less effort. You can also teach the people not to twist during the bending, or when or avoiding twisting when they are lifting the objects. As you remember, twisting and bending, especially when in combination, they can be the source of many of back injuries. Tightening abdominal muscles can help a person to have less lordosis on the back spines, and also have a good stability of the spine. It's important that during the contraction of the muscles, the person learn how to breathe, and don't hold the breath, because you need good oxygenation of your muscles to be able to produce enough energy for doing the tasks. And also it's important that you teach the people not to do any jerky movement, any sudden movement, because the tissue capacity may be beyond of the force that is producing by that jerky movement. And it's also important that you teach people that, not to twist, and if they want to pivot, they use their feet, not just pivoting by the or twisting the upper body. If the job should be done in a squatting position, again, it's important that you teach them how to have an upright position during this type of tasks, and have a good grasp, good grip, and don't not to obstruct the vision during the lifting the load, or when they carrying the load. The size of the load should be appropriate, not to obstruct their vision. Sometimes, because of the special work conditions, the person needs to lean forward for the to handle a load, and so in these conditions, we again need to teach the people how to use assisted one-handed lift. So in this case, they should use one hand on a stable surface such as a table, and then extend the opposite leg and arm to create a counterbalance. Then they should push off the non-lifting hand to raise the upper body, and not to use their back muscles too much, and apply too much stress on their back muscles. You need to teach the workers how to react and do a proper adaptation for transferring the floppy loads, such as sacks or bags. It's important that you tag these loads, that they are not stable enough, and teach the people how to handle those type of loads. So most of the preventive measurements to decrease the MMH demands are related to the type of work design and administrative issues. Poor planning of the workflow may result that the workers needs to repeat the handling task over and over, and so it's important that you plan it properly, that they have an efficient number of MMH during the task. It's important that you respect the acceptable limits for MMH, and also you can reduce the reduce the weight by assigning more people to lift the load and splitting the load in different containers, and it's even using the less heavy containers to reduce the load. And it's important that for people, if you use different co-workers for handling one load, it's important that you somehow consider their height, because if there are a height discrepancy between two workers when they are carrying one load, one of the workers may be under higher pressure than the other one. Again, by changing the work design, we may help preventing MMH-related back injuries. For example, lowering objects causes less strain than lifting objects, or pulling is easier than carrying, or pushing is less demanding than pulling. Workplace design is also very important. You can reduce the horizontal and vertical distance of lifting, and also you can reduce the carrying distance or pushing or pulling distances. You can assign more time for repetitive tasks, so the workers will have more time to rest in between. So the cumulative type of stress will be reduced. Also, we can somehow alternate the heavy tasks with lighter tasks, so reduce the buildup of fatigue. Again, I'm emphasizing on workplace design, how they design the distance of materials based on the person's anthropometric measurements, how the shelves have been designed, whether there is enough or sufficient space for body to turn, or whether the objects are located within easy reach, whether there is a clear access to the load, or the person needs to have awkward postures to reach to the load or reach to the object. The grip is good enough, or is there a handle or not. So these are the things that you can change in your workplaces to reduce the risk of increasing load on back tissues during MMH. This slide shows you the optimal working spaces. In the next class, I will talk about the works that should be done in sitting positions and the optimal working space for sitting job or office jobs. But in general, I can say any work that should be done in a hand distance forearm distance of the body, in the middle part of the body, or in preferred working zone. But any work that should be done in the area above the shoulder or the areas below the knee are somehow risky jobs. As I told you, gripping is very important for carrying the loads, not only for the back injuries, but also for preventing the shoulder, arm, and hand, elbow and hand injuries as well. So if there is not a good grip, we may sometimes need to use hooks or other facilities or handles to help transporting the loads. It's better that we use rigid containers, and also the shape of the loads should be somehow that the person can handle it closer to their body, and so less stress will be applied to their back. As I told, as we talked before, environmental factors are really important to be considered during preventing of injuries. And for manual material handling, which may be done in very high temperatures, above 30 degrees of centigrade, you should consider that the person may need more energy cost, or they expend more energy for doing the tasks during these conditions and these situations. So we need to reduce the workload, and also we should increase the resting time in those conditions. Also, the clothing should be appropriate to let the person decrease the heat absorption and also to increase evaporation. During the very cold condition, again, the clothing should be appropriate enough to help the person to do their job while protect them from hypothermia. Also, the illumination of the system of the workplace is very important for the during the manual material handling, to prevent the sudden events, and to prevent the injuries that may be caused by lack of good vision. For outdoor works, it's important that you consider the humidity and also the wind chill. So there are some suggestions that in high temperature above 28 degrees centigrade, it's better that we reduce MMH tasks to half. And when it's above 40 degrees centigrade, it's better to stop MMH. If there is wind chill and we have drop of the air temperature to minus 25%, minus 25 degrees centigrade, it's better that we restrict MMH to minimum possible. And if it is it reaches to minus 35 degrees centigrade, it's better to stop MMH, because all of these things can somehow interfere with the physiological response of the body to the load, and the physiological capacity of the person to somehow deal with these type of tasks. I hope these recommendations can help you in future if you want to work as an ergonomist in any workplace, and you want to help you to prevent MMH related injuries. But if you like to learn more about manual material handling, I recommend you to look at the book of A Guide to Manual Material Handling, written by Mittal, Nicholson, and Ayub, the very famous name in ergonomics. So you can have better understanding of the different methods to evaluate the weight limit and also the preventive measurements. Thank you for your attention. Your next class will be about the jobs which should be done in sitting position. We will talk about low back pain maybe again, because during those jobs the incidence of back pain is high again. And hopefully I can upload your second quiz on Friday, October 11th. Thanks again, and have a good one.